A needle the size of your fingertip could erase a city. Sounds impossible, right? But what if I told you a tiny metal needle, moving close to the speed of light, could unleash more destruction than a nuclear weapon? And here's the terrifying part. The smaller it is, the harder it becomes to stop. Right now, imagine a needle racing toward Earth at 99.9% the speed of light. No engines, no warning, no second chances. But before we see what happens when it hits, we need to understand why speed changes everything. Light travels at roughly 300,000 kilometers every second. That's fast enough to circle Earth more than 7 times in a single second. A trip to the moon? Just 1.3 seconds. And this is where it gets weird. According to Einstein, as an object approaches light speed, its energy skyrockets beyond imagination. The faster it moves, the harder it becomes to accelerate. Eventually, reaching true light speed would require infinite energy, which should make this scenario impossible. But what if an advanced civilization solved that problem? What if they pushed a tiny needle to 99.9% of light speed and pointed it directly at Earth? At first glance, it sounds harmless. After all, we're talking about a needle, not an asteroid, not a spaceship, not a planet-killing comet, just a thin piece of metal. But that's exactly what makes this so deceptive. Because destruction isn't only about size. It's about energy. A bullet is tiny compared to a human. Yet nobody volunteers to stand in front of one. Now multiply that idea beyond anything you've ever imagined. This needle would carry unimaginable kinetic energy. Enough energy to transform a simple impact into a catastrophe. But here's the strange part. The real danger might begin before it even touches the ground. As it slams into Earth's atmosphere, the air in front of it can't move away fast enough. Temperatures rise instantly. The sky lights up. A streak brighter than lightning tears across the horizon. People look up. Some think it's a meteor. Others think it's a missile. Nobody realizes what's actually coming. And that's when things change. Because the next few milliseconds decide the fate of millions. The needle survives the atmosphere. And then it hits. Let's say the impact point is the middle of Central Park in New York City. One moment, people are walking through the park. The next moment, everything disappears. Not burns. Not collapses. Disappears. The energy released explodes outward as heat, light, and a shockwave. Anyone near the impact is vaporized instantly. No warning. No escape. No time to react. But that's not even the craziest part. The explosion is estimated to exceed the power of many nuclear detonations. A giant fireball erupts above the city. Windows shatter for miles. Buildings crumble like dominoes. Skyscrapers that took decades to build collapse within seconds. Fires ignite everywhere. Smoke blankets the skyline. And the shockwave keeps moving. Across rivers. Across state borders. Across entire regions. The ground itself trembles. The impact unleashes energy comparable to a major earthquake. People hundreds of kilometers away feel the earth shake beneath them. But here's the twist. This may not be a global extinction event. If you're on the other side of the planet, you might survive. At least initially. And that's where the story takes a surprising turn. Because land isn't actually the worst place for the needle to strike. What happens if it plunges into the ocean? Millions of tons of water explode upward. A colossal column rises into the sky. The blast generates enormous waves. Ships vanish. Coastal regions are battered. Yet surprisingly, a civilization-ending tsunami may never arrive. Why? Because true tsunamis require entire sections of the seafloor to move. This impact is devastating, but localized. Mother Nature has produced far worse. And that's when scientists realize something chilling. There is one location where this tiny needle could become far deadlier than anyone expected. A place where a single impact could change Earth's future forever. A place already filled with pressure, waiting to explode. What happens next changes everything. Because the most dangerous target isn't a city. It isn't an ocean. It's a volcano. Imagine the needle striking directly into an active volcanic system. The impact punches through rock. Underground magma shifts violently. Pressure that has been building for centuries suddenly finds a way out. And then, Earth erupts. Not one volcano. Potentially many. Massive eruptions throw ash high into the atmosphere. The sun begins to disappear behind a global veil of darkness. Temperatures fall. Growing seasons collapse. Harvests fail. Food chains begin breaking apart. And this is where it gets truly terrifying. Humanity has seen hints of this before. Around 74,000 years ago, the Toba supereruption nearly wiped out our species. Some estimates suggest only a few thousand humans survived. Now imagine a disaster capable of triggering similar conditions. For years, sunlight struggles to reach the surface. Plants die, herbivores starve, predators follow. Entire ecosystems unravel. Civilizations crumble under food shortages and chaos. But here's the strange part. There may still be survivors. Scientists believe parts of the southern hemisphere could remain marginally habitable. Places like Australia and New Zealand might continue producing limited food supplies. Not enough for billions, but enough for a few. A tiny fraction of humanity. The descendants of those survivors would inherit a completely different world. A colder world. A darker world. A world rebuilt from the ashes. And all of it started with something smaller than your finger. A needle. A tiny object carrying enough energy to rewrite history. Thankfully, no known technology can accelerate matter to true light speed. No civilization on Earth possesses that power. At least not yet. But here's the question that keeps physicists awake at night. If something this small could nearly destroy civilization, what happens when the universe throws something much bigger our way?